everyone, this is Kalpana here. In this video, we are going to solve the given differential equation. So let's get going. Problem. Solve 1 minus x square into dy by dx plus xy equals to y cube sine inverse x. Solution. Given differential equation. One minus x square into dy by dx plus xy equals to y cube sine inverse x. Now, we are having the quotient of dy by dx, which is 1 minus x square. We always need to get the quotient of dy by dx 1. Okay. If you get some quotient, then make that quotient to 1. Simply by dividing both sides of the equations with 1 minus x square. Now what we'll do is we'll eliminate this and we'll make the quotient of dy by dx to 1 by dividing both sides of the equation with 1 minus x square. Okay. Or simply we can multiply both sides of the equation with 1 minus x square. Okay. So let's see how to eliminate 1 minus x square from the first term. So now what we are going to do is we'll simply divide both sides of the equation with 1 minus x square. Firstly, I'll write directly xy by 1 minus x square equals to y cube sine inverse x by 1 minus x square. Now I'll show you in detail by multiplying both sides of the equation with 1 minus x square. Okay. So from this we'll get see here you're having two terms in the numerator and one term in the denominator. So we'll split into two terms. 1 minus x square into dy by dx by 1 minus x square plus xy by 1 minus x square equals to y cube sine inverse x by 1 minus x square. So here 1 minus x square gets cancelled from the first term, then we'll get dy by dx plus xy by 1 minus x square equals to y cube sine inverse x by 1 minus x square. Okay, we'll get the same equation. Likewise, we'll get the same equation by multiplying both sides of the equation with 1 by 1 minus x square. Okay, we can also try this. We'll simply multiply 1 by 1 minus x square on both sides of this equation. Then also we'll get the same equation. We'll get 1 minus x square by 1 minus x square into dy by dx plus xy by 1 minus x square equals to y cube sine inverse x by 1 minus x square. Right. And now the quotient of dy by dx is 1, right? We have eliminated 1 minus x square and we got 1 as a quotient of dy by dx. So now you can write this equation as dy by dx plus function of x into y equals to function of x into function of y, which is in Bernoulli's form, right? We know that Bernoulli's equation in y and x is dy by dx plus py equals to q into y power n, where p and q are either functions of x alone or constants. And here you're having n, right? This n is a real number such that n not equals to 0 and n not equals to 1. So by comparing these two equations, we can say that we have reduced the given equation to Bernoulli's form, right? This is a Bernoulli's equation, or we have reduced the given equation to Bernoulli's form, I can say. Now, by comparing these two equations, again we'll get p, q and n, where p equals to x by 1 minus x square and q equals to sine inverse x by 1 minus x square, and compare y cube with y power n, so that you'll get n equals to 3, right? So here n equals to 3, which is not equals to 0, neither equals to 0 nor 1, and also is a real number. And here p and q involves only x and it does not involve any other variable other than x, so we call p and q as functions of x alone, right? P and q are functions of x alone and n is a real number, and also the equation is in Bernoulli's form, right? Now what we'll do is, we'll reduce this equation to linear form. We know that the standard form of linear equation in y is given by dy by dx plus p into y equals to q, where p and q are either functions of x alone or constants, right? Here p and q are either functions of x alone or constants. So now compare this equation, Bernoulli's form, to linear form. We have dy by dx plus function of x into y equals to function of x into function of y. If you compare the RHS part, in the RHS part of linear equation, you have either function of x alone or a constant, but not the function of y. But here we have the function of y. So this has to be eliminated to reduce this equation to linear form. So what we'll do, we can just take y cube to LHS, or we can multiply both sides of the equation with 1 by y cube, or we can divide both sides of the equation with y cube. Okay, now let's see what happens if we bring y cube to LHS part. Firstly, I'll write the direct step. Later we'll show you in detail. Okay, 1 by y cube into dy by dx plus x, that is function of x, into y by y cube equals to sine inverse x by 1 minus x square, that is function of x on RHS part. So let's see what happens in detail. Okay, if we bring this y cube, it becomes 1 by y cube times LHS part, that is dy by dx plus function of x, x by 1 minus x square into y equals to function of x in the RHS part, right? 1 by y cube into dy by dx plus function of x into y equals to sine inverse x by 1 minus x square. So 1 by y cube into dy by dx is 1 by y cube dy by y dx plus function of x into y by y cube equals to sine inverse x by 1 minus x square, right? So now let's see what happens if we multiply both sides of the equation with 1 by y cube. 1 by y cube into RHS part. Here y cube gets cancelled and again you'll get the same thing, right? 1 by y cube into dy by dx plus x function of x into y by y cube equals to again function of x. Okay. Now we have eliminated function of y from RHS part. Right? Then the reduced equation will be so here you're having y by y cube. You can split this as y into 1 by y cube. We know that 1 by y power n can be written as y power minus n. Then you can write 1 by reciprocal of y cube as y power minus 3. Here you will have 1, right? Now add the powers, you will get 1 minus 3, which is equals to y power minus 2. Now let this function of y be some u. Let u equals to y power minus 2. Now differentiate on both sides with respect to x. So here we'll be using chain rule to differentiate. Du, derivative of u with respect to x equals to derivative of u. This involves a function of y. So we'll get differential dy in between. Now let's find derivative of u with respect to y. You're having u equals to y power minus 2, right? Differentiate on both sides with respect to y. Then we'll get derivative of u with respect to y equals to derivative of y power minus 2 with respect to y is minus 2 into y power minus 2 minus 1, which is equals to minus 2 y power minus 2 minus 1 is minus 3. Okay. So now we can just replace dy by dx. Then derivative of this with respect to x will be du by dy is minus 2 into y power minus 3 into dy by dx. Right? Since we know that y power minus n equals to 1 by y power n, then you can replace y power minus 3 as 1 by y cube. Then this becomes minus 2 into 1 by y cube into dy by dx. Right? If you notice in the first term you're having 1 by y cube into dy by dx, right? Positive 1 by y cube into dy by dx. But here you're having minus 2 into 1 by y cube into dy by dx. So what we'll do is we'll just take this minus 2 to LHS. It becomes minus 1 by 2 into du by dx equals to 1 by y cube into dy by dx, right? So when u equals to y power minus 2, then minus 1 by 2 into du by dx equals to 1 by y cube into dy by dx. Now we can change the above equation in terms of u and x. Okay, we can also write this as in terms of y. Okay, y power minus 2 equals to u and 1 by y cube into dy by dx equals to minus 1 by 2 into du by dx. Now the above equation becomes, replace first term by this, minus 1 by 2 into du by dx plus function of x will be as it is into replace y power minus 2 by u equals to sine inverse x by 1 minus x squared. See here, the quotient of du by dx is minus 1 by 2. We have to make this to 1. For that purpose, what we'll do is multiply both sides of the equation with minus 2. Okay, see, minus into minus becomes plus and 2 by 2 becomes 1. Okay, so we'll multiply the equation with minus 2 on both sides of the equation. Okay, this equation becomes right. See, I'm not writing directly. You can write direct step. Minus 2 into minus 1 by 2. Let's write as it is into du by dx. Minus into plus minus 2x by 1 minus x square into u equals to minus 2 sine inverse x by 1 minus x square. Then you'll get minus 2 into 2 is, sorry, minus 2 into minus 1 is 2 into 2 du by dx minus 2x by 1 minus x square into u equals to minus 2 sine inverse x by 1 minus x square. Here 2 gets cancelled. Then the quotient of du by dx becomes 1, right? And the remaining terms will be same, right? Here you're having du by dx minus some function of x into u equals to some function of x, which is linear in u and x. We know that the standard form of linear equation in u and x is given by du by dx plus p into u equals to q, where p and q are either function of x alone or constants, and integrating factor is given by integral e power integral p dx, and general solution is given by y into integrating, not y here. Here use a dependent variable, right? So you'll get u into integrating factor equals to integral q into integrating factor into dx plus c. Okay. So by comparing these two equations, we can say that is a linear equation, or this is in linear form, right? Or we can say that it is linear in u. Okay. Again, by comparing these two, we'll get P and Q, where P equals to minus 2x by 1 minus x square, and Q equals to minus 2 sine inverse x by 1 minus x square, right? It involves only x. It does not involve any other variable other than x. So we call P and Q as the functions of x alone. Now, we need to find the general solution to the given equation, right? So the general solution to the obtained by this equation, that is reduced equation, linear equation in U, is the general solution to the given equation. Okay, so now we'll find the general solution to the given equation using this formula P and Q and U. Okay. So before going to general solution, we need to find integrating factor. We know that integrating factor of linear equation in U and X is given by e power integral P dx. This formula is equals to e power. Firstly, let's find integral P dx. This equals to integral minus 2x by 1 minus x square into dx. See, we can evaluate this using two ways. Firstly, by using substitution method, or by using formula integral f dash of x by f of x into dx equals to log mod f of x plus integral constant c. Okay, and one more thing, we won't use integral constant for every integral. Okay, finally we'll write only once. Fine, now let's go for substitution method. Let 1 minus x square equals to t. Now differentiate on both sides with respect to x. Then we'll get derivative of constant with respect to x is 0 minus derivative of x square with respect to x is 2x equals to dt by dx. From this we'll get minus 2x into dx equals to dt. Right? So now we can substitute t and we can replace minus 2x dx by dt. Then we'll get integral. I'll just write this as, we'll split this as 1 by 1 minus x square into minus 2x dx. Okay, it will be easy. Then we'll get integral 1 by, replace 1 minus x square by t, then you'll get 1 by t into, replace minus 2x dx by dt. Right, you'll get integral 1 by t dt, which is log mod t. Okay, there's one method. Okay, you can also use this method, that is formula. If f of x equals to 1 minus x square, f dash of x equals to derivative of 1 with respect to x is 0 minus derivative of x square with respect to x is 2x. Okay, so integral f dash of x, that is minus 2x, by f of x 1 minus x square into dx is log mod f of x, that is 1 minus x square. Okay, just substitute t here, then you'll get log mod 1 minus x square. See, you'll get the same answer. Okay, here you can use either substitution method or this formula. Okay, fine. Now finally you'll get integral p dx equals to log 1 minus x square. So integrating factor becomes e power log 1 minus x square. Since we know that e power log some function of x equals to function of x, then from this we'll get function of x. E power log function of x is function of x. So our integrating factor is 1 minus x square. Now coming to the general solution. For the general solution, to the given equation, is u into, is given by u into integrating factor 1 minus x square equals to integral q, for q equals to minus 2 sine inverse x by 1 minus x square into integrating factor 1 minus x square into dx plus c. Here 1 minus x square gets cancelled. Now take the constant minus 2 outside the integral, then you'll get minus 2 integral sine inverse x into dx plus c. Now we have u into 1 minus x square equals to integral, sorry, minus 2 integral sine inverse x into dx plus c. Since we know that integral sine inverse x dx equals to x sine inverse x plus square root of 1 minus x square plus integral constant c. Okay, then this becomes u into 1 minus x square equals to minus 2 into x sine inverse x. Integral sine inverse x is x sine inverse x plus square root of 1 minus x square plus integral constant c. Since u equals to y inverse, y power minus 2, or we know that y power minus n equals to 1 by y power n, then you can write y power minus 2 as 1 by y square. Now let's replace u by 1 by y square. Then our required solution will be 1 by y square into 1 minus x square equals to minus 2 times x sine inverse x plus square root of 1 minus x square plus c, or 1 minus x square by y square equals to minus 2 times x sine inverse x plus square root of 1 minus x square plus c. This completes the problem. So we have seen a problem from Bernoulli's equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.